Hello everyone, in this video we will be solving problem 1800 maximum ascending subarray sum. The problem statement is, given an array of positive integers nums, return the maximum possible sum of an ascending subarray in the array. If we look at example number 1 and try to portray it in a histogram kind of a format, we'll have an incremental form in the first three numbers. So it will be increasing 10, 20, 30. Then we have 5, so this is a drop. Then we have 10 and 50. So this is again an increment. So basically we have two subarrays which are in ascending order. After identifying the subarrays, we need to look at the sum and then return the maximum sum that we can build. So here for the first subarray, the total is, and for the second one, the total is 65. Which is greater, so we will return this as our output. One simple approach could be to iterate through all of the items in the array, build separate subarrays wherever we see an ascending format, and then calculates the sum, compare the sum of all the subarrays, and then return the maximum one. This will solve the problem, but it's not efficient because we may end up having to iterate through the arrays multiple times. So let's try to optimize the solution. One algorithm or approach that we can use here is sliding build, where we'll work on small subarrays that matches our criteria of being in an ascending form, and at any given point of time, if the condition is not met, we'll check the sum and then return it. For this, we'll use two variables to maintain the sum. One will be the temp sum, which would be the subarray sum that we are iterating or sliding through, and the other would be result. This will maintain the maximum subarray sum that we have calculated. Let's start the iteration where our I is equals to 0. There is nothing we can compare it because there is nothing before that, so we'll just skip that and start with I is equal to 1. So variable is 20, it is greater than the previous one. So we will add it to temp sum. Okay, so my temp sum would be 10 plus 20, that is 30. Then we'll increment our pointer to go to 30. Same thing would happen. Is 30 greater than the previous value, which is 20? Yes. So we'll add it to the temp sum. So my temp sum is now 60. Now increment our pointer, now pointing to 5. Is 5 greater than 30? No. We'll have to reset it. So what we'll do is compare this against the maximum result that we have calculated so far, and whatever is the maximum will be saved in this result. So my result will be 60. I will reset this temp sum to the current value, which is 5, so that we can start the next subarray. So this will become 5. Our pointer is at 10. 10 is greater than 5, so we will add it to the temp sum, which will make it 15, and then we'll increment our pointer again, the next being 50 greater than 10. Yes, add, so this will become 65. So we have iterated through all the numbers. Now we'll just compare the temp sum with the result and then return the maximum one, whichever it is. So our result would be 65. With this approach, our time complexity is O of n, where n is the number of items in the array, as we are iterating through the array only once, and our space complexity is O of 1. I hope you were able to understand this explanation. Let me show you how we can implement this using C#. Here's the solution in C#. We start by adding a couple of validations to check if the length of the input array is equals to 0. If yes, then return 0. Because the input array is empty. If the length is 1, which means there is no real subarray, or the one item, in the subarray there will only be one item, so return the very same item. Then I'm using a temp sum variable and the result, as we discussed in the dry run. The default value for the temp sum is the first value in the array. Then I start the for loop with I is equals to 1, as we have already included I is equal to 0 value in this temp sum. And then in the loop, I then do the check to see if the current number is greater than the previous one. If yes, then I'm adding it to the temp sum variable and continuing the iteration. But if the condition is not met, then I'm doing the math.max to get the maximum value between the temp sum and the result and storing it in the result variable and resetting the temp sum to the current number that the pointer is pointing at. Once the entire for loop is done, I'm again doing the math.max on the temp sum and the result to get the highest value and then storing it in the result and then returning it here on line 30. Hopefully you were able to understand this solution. If you have any questions, feel free to reach out to me. The link to the source code will be there in the description below. Feel free to check that out and I will see you in the next one. Thank you.